In this example, we're asked to find I naught, and that I naught is here. This is the current that we're asked to compute. And I'll utilize node voltage to solve this particular circuit. And the way we're going to do it is first we're going to identify all essential nodes, and I believe they're mostly been identified. So you have here, this is one essential node. It connects 3 different elements. This connects 4 different elements. This connects 4 different elements. This connects 3 elements. And this one here is a reference node, and this basically represents all the bottom row in here. All of these elements are connected to it, and I believe we have another reference node right here. Okay, so and it has been selected that this should be our reference node, so and it is probably a good choice. Anyway, it has been selected for us, so let's do that. Okay, so let's see how many equations do we have. Well, we have 1, 2, 3, 4, 5, and 6. So we have 6 essential nodes. So technically, we need number of essential nodes is 6. That means we need 6 minus 1 equations, which are 5. However, because we selected the reference node to be here, we can save a few things in here. So for example, we can see that this node in here, we don't need to write an equation for it because we know that this is simply 12 volts above the reference. Similarly here, this particular, well, the way I identified the first one was, well, I have a voltage source between 2 essential nodes, okay? The same goes in here. I have another voltage source between 2 essential nodes as well, so I don't need to write an equation there. Yes, this happened to be a voltage control current source or voltage control voltage source, but still I don't need to write an equation for this. How about here? Well, we have another one here, but this time none of the essential nodes that this source is connected to is a reference node. So probably what we need to do, not probably, but we need to write supernode equation in here. So that's just one supernode equation in here. Okay, and probably another equation in here. So I highlighted them in red because this is what our nodal analysis should focus on. Just 2 equations for nodal analysis, and the rest are simply constraint equations. That's what we have. Once we figure out this voltage in here, that's it. We pretty much can figure out what I naught is. So let me name the voltages that I'm after. So I will name this one here. For example, I'll say, let's say this is V1. I'll assume that this should be V2 and this should be V3, and I'll name this as V4 since it is, well, technically it's just 2Vx, but still. Or maybe I won't name it V4 so that I don't confuse you. This is just simply 2Vx, that's it. All right. So let's go about writing the KCL for the supernode. So we're going to do this here. We're going to at the supernode. Okay, so we write at the supernode again. We keep the V1, we keep the V2, and we go from there. So let's figure out the ones connected for V1. I'm gonna focus on the currents connected to V1. So we'll have V1 minus 2Vx divided by 1 kilo ohm. That's basically the current going through this branch, and I'm gonna go then to this branch and this branch. Okay, so then plus we have V1 minus 0 divided by 1 kilo ohm plus V1 minus V3 divided also by 1 kilo ohm, and that should be equal, well, it's not equal 0 because we're not done. This is actually for the supernode, so we don't write the equation for this, but because it's internal to the supernode. So we come back, we go back, or we go to the V2. So for V2, what we have is the first one here, we know already, this is just simply plus 2Ix. Okay, and we need to pay attention to the units. So if this is actually this is a milliamp, this is a milliamp, this is a milliamp, so this has to be in amps because of the 2 in here. I didn't give you the units. Typically, we assign them as amps. So this I of x is just simply in amps. So we have to maybe move it to milliamp. Okay, because I of x that we computed is in milliamps in here. Okay, so anyway, so what we need to do is we need to say, well, times 10 to the negative 3, just to make sure that this is also in milliamp, the same as the other units. So again, this is a milliamp, this is a milliamp, this is a milliamp. Well, I want this to be in milliamps, so I converted it from amps to milliamp. That's what I did. All right, so we're done with this particular one in here. So what's left? Well, what's left, I believe, is this current and this current in here. So let's do that. So we have plus V2 minus 2Vx divided by 1 kilo ohms. This is this particular voltage in here. So what I did is I said V2 minus 2Vx. All right, and then here we have V2 minus 12, which is actually my Vx, but anyway, that's V2 minus, there you go. So let me just write that in here on the new line. That's plus V2 minus 12 divided by 1 kilo ohm equal 0. So I believe I counted for all the currents. This current I did, and this one, and this one. All right, so this is just one equation. It just happened to be a large equation. And in this equation, what I do see is I have V1, Vx. Okay, so let me just write them down. This is what I have. I have V1, I have a Vx, I have V3, and I believe I have V2. Okay, and I have Ix. Well, what I need to do in order for me to solve this circuit is to just make sure that I'm finding V1, V2, V3. So I need to get rid of all these ones in here. So I need to get rid of the Vx, and I need to get rid of the Ix from this equation. So this equation is just in terms of V1, V2, V3, and Vx. All right, so what we need to do is we need to look at the constraint equations. Okay, so let's do this here. And just remember, we have to write another KCL equation for the nodal analysis in here. So I haven't gotten there yet, but I will just divert a little bit or diverge a little bit and just basically say, well, Vx is just simply V2 minus 12. Okay, so that's pretty much it. So I wrote Vx in terms of V2. So whatever you see Vx now, we're going to substitute it and it will be there. Now let's figure out what Ix is, because I have used it as a current source in here. So where's Ix? Well, this is simply Ix. So let me write an equation for Ix. So Ix is simply V1 divided by 1. All right, so now I believe that's Ix. So all we have to do is just substitute Ix by this value and we should be done. All right, so let's do that in here. So we'll go around and we'll say, well, okay, so I'm just going to clean up this equation. So I'll take these two in here and I just substitute them up so that I have an equation that contains V1, V2, and V3 only, and I'll come back. So while I was cleaning this equation, I realized coming back to these units in here. So what I've done in here is I said like, okay, so this is a milliamp. So let me just highlight the unit in here so that we're doing this. So this is a milliamp. This is a milliamp, because remember, we're adding current. So it's voltage divided by kilo ohms. This is also a milliamp, and this is also a milliamp, and this is also a milliamp. So I need to make sure that this is also a milliamp. Well, this is a current control voltage source. So the current here, it's based on a current. So if this I of x happened to be milliamps, so the source will be in milliamp too. 2 times I of x will be milliamps. What I did is I converted that to amp by mistake. So, and I realized this when I was writing the equation for here. So what I did realize is I of x, the way I computed it is the following. So what I did is I said V1 divided by 1 kilo ohm. So this here is actually in milliamp. So what I need to do when I actually was substituting that I of x in here, I realized really I do not need to do that in here. So we can correct that. Okay, and I'll just correct this in here as well. Okay, so we don't need this. Now this is the equation and I'll continue cleaning it up. And after cleanup, this is how this particular equation looked like. So we have one equation that has V1, V2, V3. We need to have a couple of other equations to be able to solve the whole circuit. So what we did is we wrote the supernode equation in here. So let's write the equation for this one in here, which is V3. Okay, so let me just do that. So we'll write the equation in here. So that's here at V3. Okay, so we're going to say that the first current, we know that the current coming in is 2x, so it's negative 2 times I of x, and plus V3 divided by 1 kilo ohm. That's basically the current going downwards. And then we have that one in here, which is simply plus V3 minus V1 divided by 1, and that basically is 0. So let's clean up a little bit. Remember, the 2ix is simply V1, so negative 2 V1 plus V3 plus V3 minus V1 equals 0, and we clean that equation a little bit, and that would look something like that. So that's the second equation here. So let me just start numbering them. So that's 1 and that's 2. Okay, 2 equations, 3 unknowns. We need a third one. So the third one comes from the supernode constraint. So we know that this voltage in here is higher than this voltage by 6 volts. So we can say that V1 minus V2 is simply 6 volts. So that will be the third equation. Okay, so we can say that simply V1 minus V2 is simply 6 volts, and that will be the third equation. So all I have to do right now is just solve these 3 equations with 3 unknowns, and I'll be able to figure out the V1, V2, and V3. So let me just do that. And the solution of these 3 equations, I rearrange these equations in here so they're easier to see. The solution for these 3 equations is that I would know what V1 is, what V2, and what V3. So let's figure out what we wanted to do. What we wanted to do is we wanted to figure out a current within that circuit in here. So that's here. So that current happened to be simply computed as, and I can write it in here or I can write it down, but that current is I naught is simply V3 divided by 1, which is V3 milliamp. Okay, so let's do that here. So the I3 is simply V3 divided by 1 kilo ohms, so that will be negative 48 milliamp. That will be the I, well, what I called it I3, it should be I naught in here, okay? So that's the I naught, and we found what we wanted. And we can compute anything else you want in the circuits. For example, you want this particular voltage, simple, it's 2Vx. Well, what's the value of Vx? Well, Vx is simply the V2 minus V1. So let's compute that since I asked for it. So what is Vx? Well, based on that, Vx is simply V2 minus 12. And we figured out what the value of V2 is. Well, negative 38 is the value of V2. So that will be negative 38 minus 12. Okay, and that will be, I believe, negative 50 volts. Okay, so Vx is negative 50 volts. That means this voltage here is double that, which is negative 100 volts. And you can go on from there and you can compute anything else you want in the circuit.